Hi, today we're going over section 3.1 and 3.2, which is solving quadratic functions by factoring. When we're given a trinomial, or in other words, a quadratic, which takes the form of ax squared plus bx plus c, we'll be able to solve for x by factoring. To factor, we'll follow a few steps. The first step is make sure everything is moved to one side. So our equation takes the form of ax squared plus bx plus c equals 0. Next, to factor, we'll find two values that add to our b value and multiply to c. So this is why this type of factoring is referred to as product sum factoring, because we want a product of c and a sum of b. Those two numbers that multiply to c and add to b are then used to create two binomial factors. If we are then asked to solve it, then we look for what values of a variable make each of the binomial factors equal to 0. So for example, solve. We have x squared plus 10 equals negative 7x. So our first step is to move everything to one side of our equation. So add 7x to both sides. So that gives us x squared plus 7x plus 10 equals 0. Now it's called product sum factoring because, once again, we have a product of this last term. So we have a product of 10 with a sum of this middle term, so 7. So we're looking for two numbers that multiply to 10 and add to 7. So in this case, that would be 5 times 2 gives you 10, and 5 plus 2 gives us 7. So it's the same numbers used in both of these. Now, how those are used with the factors is if we have nothing in front of this x squared term, both of our binomials will start with x. The numbers that then go in here are then the numbers we used here. Now, because both were positive, both will be plus 5 and plus 2. If one of them is negative, that one, we'd have x minus 2, for example. Now, this is it factored. If we want to solve it, we then look for what value of x makes each bracket equal 0. So for example, this one, if I put in negative 5 plus 5 is 0, 0 times this would give us a 0. So it's one of our answers. We'll then look at this factor, which is different from this one. So we'll have another answer. So this one will be negative 2, because if we have negative 2 plus 2, that gives us 0. 0 times this will give us our 0. Now we can always double check if we want. So this isn't necessary, but if you want to double check your answer, we can always go back to our original function. So we've got x squared plus 10 minus 7x. We can, for example, check x is equal to negative 5. So we'd substitute the negative 5 in. So we have negative 5 squared plus 10 equals negative 7 times our x of negative 5. So that would be 35 is equal to 35. So that does work. So we know that that answer of x equals negative 5 is correct. We can also check x equals negative 2. So we'd have negative 2 squared plus 10 equals negative 7 times negative 2. So that would be 14 equals 14. So both sides are the same. So that one did work as well. So we know that these answers that we came up with were correct. So once again, you don't necessarily have to check, but if you're unsure, it might be a good idea. Now we have to modify what we did slightly if we have a coefficient in front of our x squared term. And at least one answer will end up being a fraction. We'll solve similarly to before with a couple small differences. Instead of finding a product that's equal to our c term, our product is now equal to our a value times our c value. We still look for something that adds to b. And both of our binomials, instead of starting out with x, will start out with whatever our a value is and then x. Now in the end, you'll find out we have an extra factor of whatever our a value is that we have to divide out of the binomial equation. We can either divide it out of one binomial, or we can split up a factor and divide it out of both binomials. So for example, solve, we have 2x squared plus 10x equals x plus 5. So first thing I would do is move everything to one side. So I'd subtract x from both sides. I'd also subtract 5 from both sides. So that gives us 2x squared plus 9x minus 5 is equal to 0. Now in this case, our product is going to be our a value times our c value. So 2 times -5, so our product is -10, and our sum is 9. So we're looking for two things that multiply to -10, add to 9. So that would be +10 and -1 multiplied to -10. +10 plus -1 would add to 9. So we have a 2 in front here, so we start each of our binomials with 2x. And then we put in our two values. So we have +10 and -1. Now, if we look at this, we can see that if I FOIL this out, that'd give me 4x squared, because like I said, we would have an extra factor of whatever a value is in here. So we have to choose which one of these binomials we want to divide it out of. So I would probably divide the extra factor of 2 out of this one, because I won't end up with any fractions. Now, in some cases, like for example, if your a value is 6, you can break that up and divide one of them by 3, one by 2. So dividing this, we get x plus 5 and 2x minus 1. Now solving it, we have x is equal to -5. When we have a number in front of our x in our binomial, it can sometimes be a bit more challenging. So if you can't see what the x value would be simply by looking at, just take the binomial to the side, write it out, and make it equal to 0, and then rearrange to solve for x. So we have x equals -5 as well as 1/2. Next, we have determining if a binomial is a factor. If you're asked if a binomial is a factor, you need to determine whether it is or not. To do so, there's a couple different ways you can do it. One is factor it using the methods we have just gone over and see if once it's factored, one of the binomials you end up with matches one they're given. Alternatively, you can work backwards and try to create the polynomial based off of a binomial they give you. To do this, we look at what we need to multiply the binomial by to get our ax squared term, and then look at what we need to multiply by to get our c term. We'd then FOIL out and compare to the given polynomial. So we'll do a couple examples. The first one we'll use for factoring. The second one we will work backwards to create a polynomial. Okay, so example, is x plus 3 a factor of x squared plus 6x plus 9? So if we do product sum factoring, we have a product of 9 with a sum of 6. So two things that multiply to 9 and add to 6 would be 3 and 3. So this becomes x plus 3 times x plus 3. And we can see, yes, it is a factor. Okay, so the other one is x plus 5 a factor of 2x squared minus 9x minus 5. So if we do it the other way, working backwards and trying to come up with this, we know our first binomial is x plus 5. To get this 2x squared term, we would have to multiply this x by 2x, because x times 2x gives us the 2x squared. Next, we'll look at what we need to do to get this term here? Currently, we have 5. We'll look and figure out what we need to multiply 5 by to get -5. In this case, that would be -1. Now we'll FOIL this out, and if it matches this perfectly, x plus 5 will be a factor. So the main thing we'll be looking at is, does the middle term match? Because with what we've done, we know the first and last terms will. So if we go x times 2x, that gives us 2x squared. Then x times -1 gives us minus x. 5 times 2x gives us positive 10x. 5 times -1 gives us -5. So next we have 2x squared minus x. So that will combine like terms. So 2x squared minus x plus 10x. So that'd be plus 9x minus 5. Now you'll compare these two. You'll notice they're slightly different. This one's -9x. This one's positive 9x. So no, it is not a factor. Okay, so next we have a difference of squares. This is when you only have an ax squared term and a c term that is a negative value. So for example, solve, we've got x squared minus 25. Now to solve perfect squares, or sorry, differences of squares, it's actually fairly straightforward. We'll just take the square root of x squared, which gives us x, and we'll take the square root of our c value, which in this case is 5. Now in each of our binomials, we'll put the square root of the first term at the beginning, and then the square root of the second term at the end. Now it's called a difference of squares because one of them will be positive, one will be negative. So whenever we have a difference of squares, we can factor this easily. So this one, we would have the square root of 25x squared. So that would just be 5x. Then square root of 9 gives us 3. So this would be 5x plus 3 times 5x minus 3. Okay, so that's factoring them. For both of these, we'd also have to solve them. So we'd have x is equal to -5 and +5. We can write this out as plus or minus 5. Now this one, you'll also find that it's essentially two terms are the same, just opposite signs. So this one would be plus or minus 3/5. Okay, so practice for a section is on page 181 as well as 194.